Hello everybody, my name is Nurzat Mirsaliva and I am the coordinator of Industrial Energy Accelerator, which is a UNIDO-led initiative, global platform to accelerate global action on industrial energy efficiency. Energy efficiency is usually regarded as an invisible solution to climate change, and therefore it is underestimated by many stakeholders. One of the objectives of the Industrial Energy Accelerator is to make industrial energy efficiency a visible solution to climate change. And this is and the way we do it is actually by increasing awareness and increasing visibility and trying to explain more what is an industrial energy efficiency. So in today's presentation, this is what we will be doing today, is presenting various efficiency solutions that are available for industries that we as UNIDO promote in our countries, in our member states, and that of course we firmly believe in. As part of this objective, we have developed this series, Energy Efficient Solution Kits for Industries. Each kit focuses on a certain specific solution for industry. This is a starter kit, and it has a brochure, it has useful resources, video that explains a very specific solution for industry. So far we have developed 5 energy efficiency solution kits. The first one focusing on the energy management system implementation in industries. The second one is efficiency solutions for motor-driven systems. The third one is efficiency solutions for industrial heat. The fourth one is efficiency solutions for industrial cooling and refrigeration systems. And the last one is on energy performance indicators. So in today's presentation, we will briefly present these kits and why we believe this particular approach is important for improving energy performance of industries, improving their competitiveness, and also reducing their carbon emissions. Now I give floor to my colleague from South Africa, Alf, to present these kits. Thank you.
Thank you, Nurzat, and thank you, Johanna. If you could just move the slide forward, Nurzat. And I want to just add, and first of all, I want to thank UNIDO for this opportunity to share with you the work that they have done through the Energy Accelerator Forum, and I cannot see these slides moving forward.
So, I moved it already. You cannot see it?
No.
Maybe try to go out of the presentation mode.
Okay, let me try to do it again.
And while we're doing that, just to share with you that, as Nurzat said, this is not an exhaustive list of energy systems, and they've been selected really in a way because they represent the low-hanging fruit. They represent the big immediate opportunities. And thank you, Nurzat, we're on the energy management system. And we talk about this one first because in many ways, energy management systems forms the basis for what happens beyond the slide and in the other energy systems. And the reason energy management systems are so fundamental is because the energy management system we refer to and that we teach and we implement is based strongly and premised on the ISO 50001 energy management standard. And what we traditionally find in industry counter is that energy management is an ad hoc process. There's an energy office up the passage where they deal with energy projects, and every project has a start and an end. And don't we all know what happens at the end? When we've implemented, we close that chapter and we move on to the next project, and then nothing happens. And 3 years later, we're back into that scenario. So energy management systems are systematic in the way it's implemented. We don't cut corners in doing it because that guarantees in many ways its success for improving energy performance. It's applicable to a range of businesses from industrial, residential, commercial. It works in small companies, in laboratories, in research companies, in service companies, equally well and equally effective. And I've seen some really good examples of that. It's a highly effective method for decarbonization because of that sustainability about the energy management system, the way we continually plan, do, check, and act. We review progress, we set new targets, and we continue to implement those. And our experience has shown that for companies that continue business as usual, the year-on-year savings is in the region of 1 to 2%. When companies implement energy management systems, the potential that has been extracted is savings of a 15% savings in the first 2 years of implementation. And we've seen that in South Africa. We've seen that elsewhere in Africa, where that has been achieved. And what the beauty is about energy management systems is that it unlocks more than what you've just planned to do through your action plans. And we have seen that. We call it, or UNIDO calls it, the unique incremental savings. And that's incredible because through the work of the energy management system in plants or in industrial plants, we create awarenesses elsewhere in the plant. So we have almost automatic awareness and automatic projects and automatic savings occurring beyond that. And then I can't start to complete the list of non-energy benefits that are possible as well. So energy management systems forms the basis for what I'm going to talk about in the next few slides, but it's fundamental to sustaining the gains that we achieve in systems optimization. Thank you, Nuzat. Motors, electric motors are just so pervasive. You walk into a plant and there are motors everywhere. Motors in and of itself don't run and do work. Motors drive applications. They drive pumps and fans and compressors and conveyors and lifts and a whole range of things. And significant about motors, both inside the plant and in the field, that accounts for about 60% of global energy or electricity consumption. So if you want to make a change, not only your company performance, your company consumption, or your national demand or global demand, then motors becomes a surefire focused first area, and you want to look at that. And motor system savings through the work that UNIDO has done has shown, irrespective of the application, that it can generate savings of between 5 to 30%. Now, you may say to me that's a very broad band, and yes, it is. And it's broad because of the broad application that motor systems have in industry. They have a particular benefit in emerging economies where we find large induction motors operating at very low loads. And what that introduces into the grid is the poor power factor. So all the effort and cost to generate the power at the power stations are not fully utilized at the plants. And that is really almost an unforgivable excuse. Optimization leads to peak power production as we start to reduce that by using less motors or smaller motors. And the good thing about what motors does, because they operate so many appliances and applications, is that it improves operational reliability and control. Because if a motor overheats or because of harmonics, a motor fries or burns out or explodes, if you want to be dramatic, you will find that the process will come to a standstill. And in some cases, the whole section or department or whole plant will come to a standstill. And the cost of downtime to industrial plants are significant. They are huge. They overshadow the cost of getting a high efficiency motor and maintaining it and sizing it correctly, because our experience has taught us that motors are generally oversized, not only by the engineer that specifies it in the company, but by the vendor salesman who covers his or her back, and then ultimately just because of sizing it for peak loads, which are seldom achieved, results in many motors in industry being hugely oversized. Next slide, please.
I move.
Okay, industrial heat. Thank you very much. And in this energy efficiency solution kit, what UNIDO focused on was particularly the thermal loads. And, we focus on electricity, and I walk into plants and everybody's metering and monitoring, and they're hobo loggers and they're data quality analyzers and loggers, and they're logging electricity consumption. But what we often forget, and what is often not thought of and realized, is that thermal loads account for most of the global energy use. And some of the huge savings we've achieved in the IEE projects has been through reduction of thermal loads. Steam was a particular one that we focused on very narrowly within the energy efficiency solution kit. And steam is such a pervasive energy source. We find steam in steel plants. We find them in large and small and medium pulp and paper plants, textile plants, a whole range of agri-processing operations. Steam is very widely used because it has a lot of advantages. Besides being a tried and tested technology, steam has extremely efficient in terms of its high heat transfer coefficients and very cost-effective heating source compared to other sources that you may have available. And what's great about steam systems is that because of the structure of steam systems having very clearly defined components of generation, distribution, end use, and recovery, they lend themselves very well to systems optimization. And let me just pause a moment. Systems optimization versus component optimization unlocks a great deal more savings. To give you an example, simply looking at the boiler or just looking particularly at your steam traps, you may make savings, and they overall may account for about 5, if you're lucky, 7% of total fuel consumption. What is great about systems optimization is when you take all of those components into account, you can achieve savings in the order of 15 to 20%. And what makes steam systems optimization particularly important is its huge potential to reduce harmful emissions. Because in the developing world, most of the fuels that are used to generate boilers, steam boilers in industry, are fossil fuel fired. So by optimizing steam use, by optimizing generation, end use, and recovery, we ultimately save on the amount of fuel that we use in steam systems with the concomitant benefits of lower emissions. Thank you. Industrial cooling and refrigeration systems. It is often such an ignored and neglected system. And as we find in a lot of the studies that, the mapping studies that we've looked at for Africa, and particularly for the country where I come from, South Africa, is that we are seeing the progressive increase in ambient temperatures. So as we approach, and including many high ambient temperature countries, as we approach that, I find that the neglect by leaving doors open in chiller systems, having the plastic curtains broken in the refrigeration packhouses and storehouses, having competing set points for temperature units within one facility, or chilling a large area for a very small amount of produce or load within that. Those are just some of the inappropriate and poor management practices that we observe. And cooling and refrigeration systems can use up to 40% of a facility's electrical usage. In fact, in a lot of retail environments we work in, and I'm talking groceries now and even other products and related products, refrigeration and cooling can account for as much as 60 to 70% of total energy consumption. On the other hand, we find that as much as 30% of what is consumed to chill and refrigerate presents an opportunity for optimization, is unnecessarily utilized. So huge opportunities abound in the range of chiller and refrigeration systems applications. What is significant and certainly very eye-catching is when you look at the way chillers are sized and the refrigeration units are sized within industrial plants. They are sized to meet maximum or peak demand, and guess what? Maximum and peak demand is utilized over the life of the chiller and refrigeration unit only 1% of the time. So hey, what are we doing? We are sizing a refrigerant and chiller system that we are seldom going to use at its maximum capacity. And then we're sizing all the auxiliary equipment in the same way. The recirculating pumps, the fans. So we have an energy system that's woefully overloaded, and that presents opportunities for optimization and certainly reducing demand. Most of the energy systems that we work with in this Accelerator series are at the least efficient under part load conditions. And what is really developed and shown to be an excellent solution and remedy in those part load conditions, amongst others, are variable frequency drives. And we've seen enormous benefits in applying them, not only within the chiller and refrigeration environments, but more broadly in other energy systems as well. Thank you. And then I think this is the very last one. And this is fundamental and very close to my heart. But, you know, energy performance and energy performance indicators are probably some of the least understood in organizations, in industry at large. many, and historically and currently, many organizations are using energy intensity or energy consumption ratios as their measure, as the energy performance indicator. And the problem and the danger in that it can be hugely misleading if inappropriately applied. So to improve energy performance in an organization, you have to know your energy performance, and to understand and be able to measure your energy performance, you have to understand what drives that energy performance. And so often that's misunderstood. That's unknown, because we simply think by dividing the amount of energy consumed by the production units tells us how well we're doing. And in most cases, that is wrong and misleading. So understanding whether it is the volume throughput, whether it is the amount of stoppages, whether it's ambient temperature in the plant, or whether it is something else, the product quality that drives energy consumption, will help you manage those elements that affect your energy performance. So the right understanding and measurement of energy performance is critical for the implementation of an effective energy management system. And sadly, underreporting or reporting misleading results can lead to wrong decisions in industry. So energy performance measurement and indications are important enough to have seen the development of the ISO 50006 standard. And for that, we are starting to see some great awareness and application, and the work we're doing in South Africa and other countries in making this an integral part of an energy management system is starting to show some good early benefits. Thank you very much.
Thank you, Alf, a lot for presenting this. Just to add from my side that we have developed these efficiency solutions for industries based on our experience of implementing industrial energy efficiency projects in various countries for the last 10-15 years. And so these solutions, efficiency solutions kits, have been developed with the help of industrial energy efficiency experts, and each kit contains a brochure that explains what is the solution. It contains useful resources. There's also a video explainer of the solution, and there's also case studies that are attached to it. So if you're interested to get to know more about this, please visit the Industrial Energy Accelerator's website and download these kits, and please use them within your work if they're useful. Just also wanted to say that these are the type of solutions that we promote as UNIDO. So part of the kit is an infographic that explains UNIDO's approach, for example, to implementation of energy management systems in industries, and how we carry out our capacity building and training programs for industries and local experts. This is it from our side. I'm not sure if there are any questions.
Yes, there are. First of all, I would like to thank both of you for these very enriching insights. Thanks a lot. So I would just start right away with the first question from Aljona, addressed to Alfred. Where do you think a company should start?
It's a question that I'm often asked, and it's at times probably the vital first step that's important. You start by logging your consumption. You start by understanding it. And what you want to do is you start with your utility bills. If you don't have sub-metering, start with the utility bills. What are you consuming on a monthly basis? Look at your fossil fuel deliveries, your gas, your coal, your fuel oil deliveries. You start by logging that. And it's when you start looking at that and just simply working with absolute consumption, it's a good start. You want to move forward from that over time, and you want to start understanding why it goes up and down. So you want to start understanding what are the drivers for driving that consumption of that energy fuel up and down. And it's when you do that and you start to go into the kind of energy performance measurement and indicator training we spoke about, it will build the awareness and understanding not only of what drives energy, but how to apply that in modeling and developing baselines, energy consumption baselines. And that's a big and major first step. But I want to just wrap this up with one major caveat, and that is leadership. Top management commitment. You cannot go forward. You cannot go forward on your own. You cannot go forward in a corner of the plant, unknown to this is a pervasive system. So you need to get that top-down acknowledgement and support and commitment, because top management or leadership are critical in this driving the success and sustainability of energy management systems. So I hope that that helps. It is two areas that I would recommend, and then to build onto that, and then to really engage in some of the UNIDO systems training opportunities to then develop the understanding and skill sets to implement it.
Thank you. We received one more question from Marco, and I would like to try something out. Maybe we can invite Marco to the floor to just ask his question right away. So Marco, if you're with us, I would ask you to click on share audio and video and just join us here on the floor so that you can address your question right away. I see he's coming in. Hi, Marco. Nice
Hello.
to see you.
Good morning,
Hi,
good afternoon. Thank you very much, Alfred, for the great presentation. As usual, is very compelling on the value and the business benefits of energy efficiency in industry. I would like to ask you a question that came up last week in a workshop I attended with some European energy agencies. And the question or the issue is the following: whether you think that the increasing decarbonization of industry focus that has matured over the last couple of years, which I think is a great development, carries only opportunities for energy efficiency, or this great focus on decarbonization carries also some risk for work on energy efficiency? And if you see also some possible risk, if you have some ideas on how to mitigate them. But just to conclude, these colleagues from European Energy Agency, they see also risk. But I was curious also maybe your experience in South Africa. Thank you very much.
Thank you, Marco. Always great questions as usual, and so great to see you again. Marco, we have seen in South Africa for a time I won't say the devaluation, but the perceived lack of understanding of energy in isolation as a remedy, as a solution to decarbonization. And over time, we've seen a broadening of the scope of work that includes a range of measures, including energy efficiency. And I will share by way of example. So businesses are driven by ultimately bottom line, return on shares, price, earnings, yield, all those good things, whether you're listed or non-listed company. And at the end of the day, let's be frank about it, that drives it. Yes, there are a lot of other compelling issues. The ECDs, the CSIs, the environmental impact awareness, labor, employment, quality of product, market share, all of those were built in. But at the end of the day, is that bottom line. And what we have started to see is, as you say, the risk of a lot of competing priorities in a developing country like South Africa, for example. There are other measures. There's interruption of power supply. It's a far greater and has a far damaging impact on a company's profitability and existence than 5% improvement in energy efficiency. So we've experienced some of that, and we experienced some of the challenges in terms of just market growth, declines of markets, softer markets, strengthening markets. So I've seen the response, the effective response to that in South Africa has been by presenting a complete package, by looking at just the operational cost in the business, of which energy is quite an important component, and addressing that in an overall fashion. So I've seen large consulting firms take teams into organizations that have a whole range of skills, from the process-related skills peculiar to that
I think we lost Alfred.
Connection problem, maybe.
Yes, that's possible. Okay, maybe in the meantime, while Alfred tries to reconnect, thank you, Marco, first of all, for your question and coming to the floor.
I think it already provided a good answer to the question. So thank you very much, Joanna and Nurzat.
Thank you, Marco.
Thank you, Marco. We have one last question in the chat. Maybe, Nurzat, I will address that to you. So there have been a good overview of the toolkits, of the different kits you developed, and there seems to be so many opportunities in industry. So why is energy efficiency seemingly so overlooked, and what is the Industrial Energy Accelerator doing to change that?
Thank you, and thank you for asking this question. Welcome back,
I'm not sure
Alf.
you can hear me.
Yes, we can hear you.
We can hear you, Alfred. Thanks. We passed on to the question from Janina. And Marco said, thank you for your answer. You already answered his question quite well.
I can't hear you, but I'm going to just finish off anyway. So yes, we've seen a broader response that deals with the operational issues, including energy. So energy is a component of a more broader package of measures to improve company and resilience against the kind of things that I mentioned we encounter in the developing world and in South Africa particularly.
Thank you.
Thank you, Alfred. So maybe Nurzat, you go on with the other question?
Sure. Energy efficiency is often overlooked because it's not easy to visualize it. One of the reasons, right? It's not like solar panels or windmills where you can see very clearly the renewable energy. So energy efficiency, and specifically industrial energy efficiency, is a complex of measures. It's very hard to pinpoint to very specific technology and say this is an energy efficiency measure. It's a complex of measures. It includes upgrade of technology, change in your behavior, right? Also implementing a new energy management standard, etc. So that's actually one of the reasons why it's hard to imagine and visualize and understand what energy efficiency and specifically industrial energy efficiency is. So what we're trying to do through Industrial Energy Accelerator is actually to bring more visibility to this subject by increasing awareness of what is industrial energy efficiency, by demonstrating best practices through case studies of type of industrial energy efficiency measures that can be implemented and what are the business cases and benefits it has provided for that particular industrial facility, but also for the country and for the planet at large. So that is how we try to increase the visibility of industrial energy efficiency by making it more visible and demonstrating the impact of these measures. I don't know, Alf, maybe you could, you probably don't hear me, if you could add, but if you can hear me, of course. Okay, now you can hear me. Yes, this is it. I hope I answered the question.
I think so.
Hello.
Thank you, Nurzat. I hear you, Alfred. I think you don't, right? Okay, he's reconnecting. Maybe we're just closing the session. I think we answered all the questions which are there. I'm also posting a link into the chat for further information. Mm-hmm. And as I said before, we will share also the recording afterwards in the booth. So everybody who wants to join later can just watch the session again. So thank you very much, Nurzat, for these really nice and interesting insights. And I will also say thanks to Alfred once again when I have him on the phone. So thanks a lot and have a nice day.
Thank you, Johanna. Thank you, Alf. Have a good